Hey guys, welcome back. We're going to be looking at Leetcode 203, remove linked list elements. We're told that we're given the head of a linked list and an integer val, and we need to remove all the nodes of the linked list that has node.val equal to the value and return the new head. So in this example, we've got 1, 2, 6, 3, 4, 5, 6, and the value is going to be 6. So the output we want to return is 1, 2, 3, 4, and 5. Without the two sixes. So we need to basically skip over those nodes where the value equals the value that's given in our remove elements function. We're given two more examples and we're also given some constraints. So let's hop straight into the code. As with all these problems, let's create a dummy node, which is going to be set to just a empty list node. We'll set dummy.next equal to our head. The reason we're going to do this is because it could be our head is the value of our head is equal to the value that we need to remove, in which case we need our dummy node. Otherwise, our head node, we won't be able to do anything with it. We won't be able to point it anywhere. So we need the dummy node. Dummy.next will always be our head. And then we'll have current, which will be equal to our dummy. And this is what we can traverse. We use to traverse. So we'll say while current as well as current.next, because we want to check for the next value. We'll say if current.next.value equals the value, so our target value. In that case, we will say current.next equals current.next.next. So current.next, let's say our value current.next is 6. Well, and the current.next of 2 is 6, so we will say current.next is current.next.next, so it will be 3. Otherwise, we're just going to say current equals current.next. Fabulous. And once this while loop is finished, like I said before, our dummy.next will point to the new head. So let's run our code, check if this works. Submit our code. We pass all 66 cases with quite an optimal solution. So in terms of time complexity, it's a single pass. So it's going to be O event time complexity, and we're not storing the list nodes anywhere, so it's going to be a constant O of 1 space complexity. So I hope you guys enjoyed this video, and I'll catch you in the next one.